Hello, what's up, guys? I realized that I did not explain this example particularly in detail just now, not detail enough at least. So this video I'm going to try to re-explain again the same example, but hopefully this time will be much more clearer. And I also realized that there's a slight error with the diagram that I posted in the slides, and I'll explain to you where the error is in this video. All right, so this was the video, this was the example that we covered just in the class. So let me, all right, so suppose we have this circuit over here, and this circuit over here has I0, I1, and S. So, and suppose we want to illustrate what kind of hazards that's present in this circuit. So what we want to do is to draw the timing diagram, because only through a timing diagram you can exactly know where is the hazard. Okay, so let's start by drawing this timing diagram. So in this question, okay, so in this question, it's specified that a NOT gate has a zero point 0.5 nanoseconds of propagation delay, and all other gates have 1 nanoseconds of propagation delay. Okay, so just keep this in mind as we draw this circuit over here. So this timing diagram over here, suppose the input we want to test is this. So I0 and I1 will be constantly high, and S will change from 1 to 0 and back to 1. So now we are going to start drawing the first waveform for S bar over here. So where's S bar in the circuit? S bar is here in the circuit. Okay, S bar, and suppose we have intermediate output over here. Call this K0 and K1 just to be consistent with the timing diagram. Okay, so let's start by drawing the output waveform for S1. Okay, so S1, bear in mind, S1 goes through this NOT gate, and it's got this propagation delay of 0.5 nanosecond. So how does the 0.5 nanosecond looks like? It's like half of this, because one how to say one bar over here, like, is 1 nanosecond, so half nanosecond is going to take like half of this. Okay, so right, let's begin. So S bar, as you can see over here, it depends on the value of S. So what's the value of S over here in the beginning? It's the value of S is 1 in the beginning, and so what an inverter does is going to invert that into a 0, right? That is how you would normally draw this diagram. So 1, and over here it becomes 0. But that is not considering the propagation delay. So if you consider propagation delay, what's going to happen? So you're not going to draw this starting from here, because propagation delay of 0.5 millisecond means that this NOT gate over here, it takes 0.5 milliseconds to process whatever input. So 1 over here, it's going to become 0, but it's going to become 0 after a delay of 0.5 nanoseconds. Okay, so this is, I should probably draw this better. This is the 0.5 milliseconds. So for 0.5 milliseconds, it's not going to produce any output, because it's just processing whatever that you give over here. So 1, and then after 0.5 milliseconds, and then it produces the output, and then it's 0 here. Okay, now the same thing over here, and you input the value 0 again. Sorry, you input you give an input of 1 again, and it produces 0. Okay, so you give input for 1, the duration doesn't change, right? So you can see the duration here is 1 nanosecond, and the duration over here is also 1 nanosecond. The duration doesn't change, so what change is just it's delayed. Okay, it's just delayed. It's just shifted to the right because of the propagation delay. Okay, all right, so that is this portion of the signal. So if we input again this portion of the signal, and it produces this portion, and then you input this portion of signal, now it changes, you input 0, you input low, and this is going to give you high with the same amount of duration. This is from here to here is still 1 nanosecond. So here is still the same, still 1 nanosecond over here, and over here, this portion, so it's going to invert. This becomes low for 1 nanosecond, high for 1 nanosecond, it becomes low for 1 nanosecond, high for 1 nanosecond, it becomes low for 1 nanosecond. So that is how we get the uh, waveform for S bar. Okay, clear? Okay, now we are going to see how we draw the waveform for K0. For K0. So let me change my pen color so that it's clearer. Screen pointer option in color. All right. So for K0, so we see that K0 has a K0, so it can only be produced. The value of K0 can only be produced after it's gone through, after it's got the value of S1. Okay, after it's got the value of S1, meaning to say over here. So for this region, um, for this re oh my for this region over here, there is no output. There's no value produced because there's simply nothing to process, because this region over here doesn't have any input. Okay, so K0 can only be produced after it's got the value from S1, because S1 has got this delay. Okay, so now we are going to start drawing K0. So for K0, it's going to do an AND operation between I0 which is on top over here, I0 and S bar. Okay, so it's going to be the same. So we're going to see the region that has no signal, we cannot process it. So K0 has no signal for the first 0.5 nanosecond. So the first time it gets the signal is here. So we have low, and over here we have half nanosecond of high. So high and ended with low, you would get a low, right? Low. So you might be tempted to draw this over here, but remember, this gate also has propagation delay. So, and how much exactly is delay is 1 nanosecond. So instead of drawing here the output waveform, you gotta delay this by 1 nanosecond. Okay, 1 nanosecond. So 1 nanosecond it means that you gotta delay. Here's half, the other half is here. So you can start drawing here. Okay, so get high and low. The result will be low, and it's delayed by exactly, this one is 1 nanoseconds. Why is it 1 nanosecond? Because it's specified over here that this AND gate and OR gate has a delay of 1 nanosecond. So okay, all right. So for the initial part over here, the gate there's not it's not going to have any output because the signals are not defined. All right. Okay, so that is this portion and this portion of the signal. So now let's advance into the next portion. So if we consider this portion of the signal one high and this portion of the signal low, so high and low, you produce AND gate and those operations together, you still produce low. Okay, and how long that signal remains low, because we are only considering one segment of 1 nanosecond, so it's going to stay low for 1 nanosecond. So we do the same over here, high and low, so it's going to stay low. Okay, so here is where something different. Okay, so because we only have half segment over here, and we're going to take just half segment, so half segment here, half segment here. So this will be high, and over here it's low, so it's still going to stay low. Okay, and what about the other half? High, and then we're going to stay here is high, so we are going to be high. The signal is going to give you a high output for half in nanosecond. Okay, and then it's going to stay, this one's high and this one's high, so it's going to stay high over here, and this one's high. Oh, sorry, maybe I shouldn't take the full segment because there's only half over here. So you have half segment of high, and I'm going to take half segment of high over here. It's going to produce half segment of high because AND operation, and then it's going to be high, low, high, low. It's going to give low, and get high, low. It's going to give low, and you got high, got low. It's going to give low. Okay, so I'm just going to start drawing here, stop drawing here, because that's the end of our timing diagram. Okay, so that's how we produce the output waveform timing diagram for K0 here. Now let's take a look at K1 right now. K1, so K1 it's the same thing again. It's got 1 nanoseconds of delay because of the AND gate. So let's try to draw the waveform for K1. Pointer, okay, let me change my ink color so that it's obvious. So K1's got to consider the input from I1 and S. So I1 is over here and S is over here. Okay, so this one has no intermediate NOT gate here, so we can just do we can just draw it directly. So I1 and S, so it's going to be an AND operation. This is AND gate here. Okay, so 1 and 1, so we got high and high, so K1 has got to be high here. Okay, you might be tempted to draw that, but if you consider propagation delay, you cannot start drawing that. You got to start drawing after it's delayed by exactly 1 nanoseconds. So that means that the signal only comes out after 1 nanoseconds. So you got to start drawing over here. And for the initial portion over here, there's no signal coming in. There's no signal that's produced as the output. Okay, so this is the delay over here. Okay, right? So 1, 1. So same thing over here. You have 1 and 1. 1 and 1 is going to stay 1. And you gotta have 1 and 1 also. It's gonna stay 1. And you got, now it becomes 1 and 0. Okay, 1 and 0, then it's gonna dip here. 1, 0, 1, 0. It's gonna, I'll put a 0. Now it becomes 1, 1 again, and then it's gonna go back up 1, and it's gonna go back 1 and 1 again, and then it's gonna go out. Okay, so this one, okay, so here, okay, I'm just gonna stop here. So that's how we get a signal for K1, right? So finally, how do we get the output? So the output now depends on the value of K0 and K1, right? So let's take a look. Let me change my ink color so it's easier to see. Ink color, let's take purple. Okay, right, so the output is going to be dependent on K0 and K1. So for the output to be produced, we've got to wait until we have signal from both sides, from K0 and K1. So our drawing will only start right here because K0 only starts giving an input at this point. Okay, right. So now we are going to see, so for this portion of the input and this portion of the input, we are going to OR it. 0 or 1, 0 or 1, 0 or 1, we get 1, right? So we're going to draw here 1. Oh, okay, wait. If you consider propagation delay of 1 nanosecond, you cannot start drawing from here. You got to start drawing after it's delayed for 1 nanosecond. So exactly, we will draw 1 nanosecond. It starts here. Okay. Now this is 1 nanosecond. Okay, right. So that is this portion. So if you consider this one, 0 and 1, 0 or 1, 0 or 1 is going to get 1. I'm taking the full segment. 0 or 1, again, is going to be 1. Okay, now the next segment is just 0 and or 0. 0 or 0 over here is going to give you a 0, and then the next segment is 1 or 0, and then it's going to give you 1. And the next segment over here is 1 or 0. It's going to stay 1, and it's going to stay here 1, or with 1 still 1, 0 or with 1 still 1, and then like 0 or 1. So, okay, I'm just going to stop here. So so the signal, the output signal is undefined for this period of time in the beginning, because it just doesn't have the necessary signal to produce any output. So what we are seeing over here is a glitch. So in the original timing diagram without propagation delay, the output stays 1 at all times. But what we are seeing here is because of the propagation delay, it is creating a momentary 0 value at the output at this point of time. And this is what we call a static 1 hazard. Okay, and that is how we visualize hazards or glitches in circuits using a timing diagram. Thank you. Hope it helps.